Okay, here we are going to go over two problems from the formative that have to do with M47.2. These are actually from formative 7a, and these are going to help you with the summative, which will have several problems from M47.2, which basically is applying trig in real-life situations. So, this asks us, it says a driver uses a ramp when unloading supplies from a delivery truck. Here's his truck. Yeah, that's right, I just drew a truck. And here's the ramp. Now, it says that the ramp is 15 feet long, so this is 15 feet long. The ramp is obviously the inclined part of the diagram, and so make sure you have that as 15 and not this down here as 15, because that down there is not anything that we've measured so far. So if they say the ramp is 15, we know that we have a 15 right here on the hypotenuse of the right triangle that we're about to draw. Now it also helps to have a line that represents the ground, because it does say to the nearest angle what angle does the ramp make with the ground. So here's the ramp, here's the ground, here's the angle that we must be looking for. The one piece of missing information I haven't gotten the diagram yet is it says that the bed of the truck is 5 feet off the ground. So again, here's the ground, and here is the 5 feet. Now, we do have a right triangle here because the ground and the height will be at right angles to each other. So all we need to do now is think about it. We want an angle. Okay? We want the angle. We know the opposite side of the angle. We know the hypotenuse of the angle. Which of the functions involves opposite and hypotenuse? The sine does. So the sine of angle theta must equal 5 over 15, opposite over hypotenuse. To find theta itself, we need to do the inverse sine of 5 over 15. And when we check in with our calculator here, unfortunately I'm not recording a big enough piece of my screen where we'll be able to see all this at one time, but we'll go second function sine of 5 divided by 15, and we'll press enter, and we see the angle is 19.47 degrees. It does say to the nearest degree, so we'll go theta equals 19 degrees. This next one won't need the calculator, which is good. Okay, we have the diagram already set up for us. We can read the problem again if we need to, but it basically is asking which of the following expressions expresses the horizontal distance in meters between the base of the two poles. So this is what we're looking for right here. If you notice, we do have a rectangle, so whatever we're looking for right here, question mark, will also be the same question mark as we have right there, which is helpful because now that we have that, now that we know we're looking for that question mark, we can see we have a right triangle, and we know trig is all about right triangles, and it's going to be able to help us to find that question mark. So right now we have this angle. We want this side. This side is the adjacent side to 15 degrees. We're going to need one of the other two sides if we want to use trigonometry here. And fortunately we do have this side right here, because if you think about it, the total distance from bottom to top is 5. The distance from bottom to the adjacent side of this part of the triangle is 3, which leaves us only 2 left over for that part of the triangle. So we want the adjacent, we have the opposite side of 15 degrees. Which function involves opposite and adjacent? Tangent, of course. So the tangent of 15 degrees must equal 2 over the adjacent side. Now if we want to get the adjacent side by itself, we're going to go ahead and multiply both sides by the adjacent side, and so we have adjacent side times the tangent of 15 equals 2. And then now to get adjacent all by itself, we're going to divide both sides by the tangent of 15. So the adjacent side must equal 2 divided by the tangent of 15, which is option E. So overall with these two problems, what I want you to remember is find out, you may need an angle, you may need a side, but you got to think about what sides you have and which sides you want, so that you can decide which of the functions you should use. Do I want to use sine? You would use sine if you wanted the opposite or the hypotenuse. You'd use adjacent or you'd use cosine if you wanted to use the adjacent and the hypotenuse, and you'd use tangent if you wanted to use the opposite and the adjacent.